In this episode of Finno Machining, we are still working or playing with the Russian dividing head. Namely, as you maybe noticed in the last episode, I noticed that there is some play. And now I will try to eliminate most of this play. Furthermore, there are, this is a good exercise in precision machining, actually. So, let's start with analysis of what kind of play we have in this dividing head. This here is my PlayStation. So, the play in this head consists of several components, so to say. It is, first of all, we have this shaft, and there is some radial play on this one. That's radial play means this type of play in the sideways. So when I put it here, without any other components, so without the bearings in the backside, etc. So I actually, if I wiggle the backside, there is some play there. Not a lot, but there is some. And there is nothing we can do about the play in the backside. Then, of course, we have play in the front side, but this one can be eliminated by pushing this in, because there is a taper in this one, and when you push it in, you can totally eliminate that play. The knock comes from the backside here. That's quite loose. So we need to adjust this somehow, the depth how it goes inside, to a precision value so that it doesn't bind, but it doesn't have a lot of play. That's not easy. This one does not have adjustment for that. That I have now realized. And then we have radial axial play, like this type of play, back and forth. Well, that's easy enough. It's just adjusting the backside bearings, putting them tight enough, so then you are getting rid of the axial play. So that's one. And then we have rotational play here. I mean that because this is a dividing head, you should stop at some point and stay there. First of all, this has the direct indexing system, which consists of this, actually this is impacting on the key here, on the keyway. Now it's loose. Now it's a little bit tighter, but it's still not tight. So you put it, that's really loose. Okay, so you put it there, and then this is the direct indexing gear. It's a gear actually. So you put it like there, and then there is a lot of play in that one. That's almost a degree. So what I have done here to eliminate that, I have put group screws here. I drilled and threaded this thing, and I have now group screws here and another here. So when you tighten them, they go into these dimples I also made in this shaft, and then the play is gone. Of course, this doesn't take a lot of torque after that, so that's one source of the rotational play. Then we have the indirect indexing thing, and this one involves this gear. It had the same play like that one had. It goes this way into the shaft, and this has at least as much play as the other one. So, and it will be eliminated in the same manner. I have here these dimples, and then I have here group screws. We end up eliminating rotational play on the shaft and gear systems, I think, totally. Well, those are now the rotational play and radial play. Now, to eliminate the radial play here on the table, this is a little bit more involving. This is now PlayStation version 2. The axial radial play on the nose side here, not in the back side but on the nose side. Well, this is now something that is not so easy in this case. So first I will put this this shaft into here, like that. And then we had this. This is the direct indexing gear. That was one. Then we had this washer, which is in between those things, and then we have the warm gear going there as well, like that. Now let's put all this together. Okay, now it's there. And now what we have here is that in that cap here we should have a bearing and a spacer. And at the moment the spacer looks like this. Not a thing that I would call a precision thing. And the bearing and the spacer would be such that when you draw the bearing tight there, or suitably tight, they should take all the space here and leave just enough so that this can still rotate freely. If it pulls it too much into the taper, this won't turn anymore. So we need to measure that gap actually. And that is exactly what I'm going to do next. And for this thing I'm going to use these parallels, which I just put into that gap. Something like 15.5. And now I'm adjusting the parallel itself, so that when I put the parallel there, the taper should not bind, but it shouldn't have any. Now this is 15.5 exactly. So we are 1/100th of a millimeter wide, are we? Yes, we are. And now it's tight. It's really tight. I have to knock it out from there. It binds so tight when it binds that. Now let's put this parallel in between here and see. Well, it's still loose even though so that's not the correct value. So we have to make it wider, even wider. 15.6. Now this is 15.6. It's still loose there. 15.6 is still really loose. And this is now 15.7 millimeters. It's still Now it's on the edge because there is no play on the parallels but the shaft is binding. So we need to take 15.75. Oh yeah. I think that's our measure. It still turns, but there is no play. And this is in the edge of starting to bind. So probably if you have a bearing there, and when I measure the bearing and when you tighten it, it will squeeze down and it might bind this one. So let's try 15.8. So 5/100 of a millimeter more. Let's see how much more does it add to the play. Is it now 15.8? Let's see if it is. Well, 15.8. I believe this is 15.8. Okay, now it's 15.8, and we put it there in between, and it rotates really freely and didn't add a lot of play into the shaft. Okay, 15.8 works. How about 15.85? I just want to see what the tolerance is here. Now I push it there, like really push. It rotates even though I make this. Doesn't add a lot. Now I have determined that this cap should be 15.8 millimeters. Here I'm trying to measure the height of this bearing. So I have a parallel here under. This I assume it's quite straight, the surface. At least it is surface ground. So yeah, and then I have cleaned up the surfaces quite thoroughly. There was some dings, I have stoned those away. So now we take our depth mic and well, it's there is nothing in between, so I just put this here and there you go. That's our first measurement. And this one is now reading the depth mic is well, it looks like we have 13.05. True? 13.05 maybe. Let's rotate it a little bit and take another measurement. I'm pushing it really hard down. So now 13.05. Okay. Then we turn this around. If it's somehow crooked, see that there are no dings under, and take yet another measurement. 13.05. Okay, this looks like we have a 13.05 dimension here. These are quite consistent. Yeah, 13.05. Okay, let's trust on that one. So 13.05. Now this is the total dimension, and that one is the bearing height. So actually we should subtract the bearing height from that dimension, and then we get the spacer height. So minus this will come 75.2. Correct? So That's our thickness of the spacer, and this was the original one that was sitting there just for curiosity how much this is nowhere near. So let's see how much is this. If I can get it into the, yes I can. So I can take a measure. Okay, now 1.55 maybe. So I assume it's way too tight for that thing. It means that the taper draws in about 1 millimeter even, and well, that's too much. And I noticed it. You couldn't get it. It was binding very easily. So once you hammered something on the nose, it started to bind. Not what I want. So that's our goal for the spacer. It can be, I noticed that it can be even 2.8 millimeters, but it shouldn't be, well, it can be also 2.7 millimeters, but it cannot be like 2.60, no, 65, too tight. 70 is okay, but it's almost tight. 75 is the best, and 80 here, 2.80 is also good, but it's maybe there are some play in the nose. So 75 is our optimal. It's right in the between of usable values. So next step, it's a late job, this one. parting tool which I'm going to use next to separate our spacer from this workpiece. So what I have now here aligned this edge of the cutting tool with the to be plain with I use this tool for that, and it's quite accurate. I can tell you can put it somewhere around maybe 300ths of a millimeter at least, that accuracy. So now we have it there. Now the only thing is that we need to move this parting tool towards the chuck 2.75 millimeters. Easy enough. So that was 1 millimeter. Then we have 2 millimeters. And then we have 2.5 millimeters. And 2.75 is there. And then I lock, well, the carriage is of course locked. And now I will also lock the compound here. Well, and now we cannot run this like 800 revolutions per minute. This is going to be really slow. Maybe that one. Let's take the tool a little bit out so I don't start rubbing right away. Let's see. That's already, believe me or not, too fast. Now it's 85 revolutions. That looks more like that. And now I just cut it. First of all, I want to know what kind of sound we are getting here. So not too bad. I want to cut this really slowly. And it's cutting really nicely actually. Well, should I use the automatic feed here? Let's see. Yeah, okay. It makes a better surface finish on the piece if I do it this way. Let's see how this automatic feed works. Oh, it works. So, quite well actually. Good. Well, it tries to chatter on me, but it just tries. Any moment now. Yeah. No. The following procedure comes with the risk of hand injury. You have been warned. Well, in this ring we have at the moment 300ths of a millimeter extra thickness. How to get rid of that? It's not very easy, but you can do that. Actually, you can do this with your bench grinder. You just, I have made here one marking like that. When you put it here, like this, even so gently, and hold it in place so you can, it rotates by itself. That was one turn. And another turn. Let's see, I will check now what we have here. Well, we still have 200ths of a millimeter. So where was my marking there? So, oh, it rotates really fast. I don't want that. Just want to be perfect with this one. Okay. There you are. That's exactly, and the other side is exactly. Yeah. I will show that to you. So now, Arga, where is, that's the frame. So if I measure it this side, there is our 75, and then I turn it 180 degrees and take another measure, it's again. This is really, it became really exact. And the surface finish is like it would have been ground. Well, actually it is ground. This is now our new spacer. So what I will do now, I will not use a hammer to get this everything together. So first of all I will put this here, and I have made everything clean and such that they slide easily on the surfaces. Made sure that these really slide, because now for the next operation it will be important that these things won't bind at any point. So now I put first these heavier things here on the shaft, and I'll put them in a way that they are ready to go in. Let's see now. Yes. And they slide really free. And then goes this one. You remember this? This is the new spacer. Goes in there very nicely. And then we have room for the bearing. And now what I will now do off the camera, I will warm it up to quite a high, no, not a high temperature, 200 degrees Celsius maybe. And after that I will put the tight bearing there, and then I will put the loose parts there. Then I just push everything together. It should go quite freely. So here is the thing. I need to have a glove. And then I take this ring, which is now quite hot actually. It's about 250 degrees Celsius. I just put it there hanging. This is the rest of the bearings. Hopefully I don't burn my fingers here. I got them in place. And then I slide in this. I need to have all my fingers here. Hopefully I can get this going. Yes, I got it going. Okay, it went quite well actually. Oh, I got it in place in one go. Nice. It went just slipped in. And now I can, well, it's perfect. It's really nice. Let's take my plastic hammer and make it sure that it's there. I said I don't need the plastic hammer, but you have to make sure. Yeah, this is. There is not much of play, and this is really nice. Wow, I think this I got it right. And then, of course, with the backside bearing, we can use the same trick. Heat it up, because the loose end goes inside against the casting, and then only this outside needs to be warmed. So, served, best served as hot. Yeah. So this ring this is the tight one, goes there, but oh, and believe me, it's really hot. So I'm using this to push it in. Should go, yeah, it went there without any trouble. I will put this one to tighten them. I will loosen this after this. Yeah, you can. And now I'm just waiting that it cools down. And now I put this here. Like that, and that goes then behind it. It is these group screws. That one first. Just tighten it. And then this one. Okay, that's a good angle. Well, I cannot see anything. There is nothing. Absolutely nothing. Yeah. So this way, no play. This way, 3/100 of a millimeter. Is it too much? Might be. It will go lower. There is no oil at the moment. Oil film will make it smaller, because it does. And well, then I would like to see how much do we have while we are on it. Let's put this here. Well, do we have that much really? And the play is about 3/100 of a millimeter. You might see it. Yes, you can see it. It's a 3/100 of a millimeter here. And let's see how much we have play in the Morse code. If I can. This is not a reliable measurement, because there is a cosine error here. And the meter is not even touching at every time. Okay, there it is. Now it's touching all the time. No, it's not touching. I cannot say how much is that. So how about this surface? We have the same error there. Well, there is some wiggle. And the notable thing is that it's more than the wiggle, more than the play. It is amazing what a little bit of oil can do for your thing. I remember it was about 0.1 millimeter the deviation there. Well, not that much, but quite a lot. So now, if I rotate this, there is still something, but it's like 3/100 of a millimeter at this time. And then the side play, you can get the same play, but you definitely can see how it's harder to push it around, and this is because the oil is taking some of the place, and there is this hydrodynamics going on in the bearing. But now, and it of course it became a lot smoother. Okay, just to show you here that oil has some impact, especially on the concentricity. This concludes this episode of Finnugrid Machine. The play in the resulting play in the nose, the radial play is at the moment 3/100 of a millimeter. Maybe it's too much, maybe not. It depends how you think about things. For me, this is okay. And then the axial play, there is no axial play. And then the rotational play on indirect indexing is about half degree. It was 5 degrees earlier. Same about the indirect indexing, which is even smaller at the moment. So I successfully moved the decimal point. So I think this is totally usable at the moment. And I can use it, really I can use that. So, in the next episode we finally get into the rotating welding positioner. Till then, bye!